Student learning objective, solve absolute value inequalities. In this case, we want to solve this inequality and answer in interval notation. Now, first thing is we need to isolate the absolute value. So we add the 8 first, leaving us 3 times absolute value 2x plus 5, greater than or equal to 27. Then we divide by the 3, and we're left with greater than or equal to 9. Dividing by a positive 3 does not change the inequality. If you divide or multiply by a negative, make sure to switch your inequality sign. Now at this point in time, we have two possible approaches. One approach is to split this up into two inequalities, like the 2x plus 5 greater than or equal to 9. This is an OR. And 2x plus 5 is less than or equal to negative 9. Solving each of these would give us 2x greater than or equal to 4, that is x greater than or equal to 2, or 2x less than or equal to negative 14, so that's x is less than or equal to negative 7. And on a number line, negative 7 less than or equal to positive 2 greater than or equal to. Because this is an OR compound inequality, we can take any of this solution as the final answer. So our final answer is from negative infinity to negative 7, hard bracket, union hard bracket from 2 to infinity. That's one approach. The issue is people forget to switch the inequality on the right one or on one of them, and then the sign as well, the sign of the number, and knowing that it's OR. The other one is to know that basically if we have an absolute value is like greater than or equal to 9 on a number line, obviously 9 would work, but so would 10, so would 11, because we plug these in. 11 is greater than or equal to 9. In fact, anything to the right of 9 would work. But also on the left side, negative 9 would work because of the action of the absolute value. You plug negative 9 in, the absolute value makes it positive 9. 9 is greater than or equal to 9. Negative 10 would work. Negative 11 would work. All these numbers. So we end up with this form of the answer. Now, of course, this is a slightly different problem, but knowing the form of the answer, and we can see the form is correct. The form is the left half, or the left to some number, I don't know what the number is, and then from another number to the right. If you know the basic form of the answer, that this is this form, greater than or equal to a number, positive number is always this form, then you can change to an equation. If I look at the equation instead, absolute value equations, there's no switching the inequality. There's no inequality. There's no and or stuff. We just go to 2x plus 5 could equal 9. 2x plus 5 could equal negative 9. And solving each of these, 2x equals 4, so x equals 2. And 2x equals negative 14, so x equals negative 7. Negative 7 is to the left on the number line, positive 2 is to the right. And we're able to get the answer by solving equations instead of the OR inequalities. You do need to know what the basic form is. But it's a nice way to go if you like it.